Um, anyhow, and I see there are some, let me turn on the chat. Okay, so you're all talking about the schools. I'm on a small screen here, so I'm turning the chat back off, but it will alert me if there are chats to look at. First off, I mean, if you just are, let me go over here and pull up a file. Give me just a second here. Most of the data that I received, and plus most of the data that I have worked with from like Qualtrics or other survey software, when you report out that data, you have some options. And what I've sort of discovered over the years is that those options are somewhat problematic because they don't stay up to date. And so as new versions of file formats and all come out, and you get an upgrade in, say, Excel, it may not, what's coming out of a piece of database software may not be aware of that upgrade, and so it may not have full functionality when it gets into something else. And so if you ask for information to come out of database systems or survey software, things like that, as in the form of a SPSS file or a SAS file or something like that, so that you can dump it straight into a database, into a statistical piece of software, a lot of times it has lots of little glitches in it. And it takes a fair amount of time. It takes more time to clean it up than it does to run the analysis. And so what I found that almost always works every time is to save stuff out or to export stuff out into what are called CSV files, comma separated files. And there is a version of CSV files, and generally when you save stuff out as CSV files, it comes out in what's called an Excel.csv file. And then that loads directly into Excel. And so that's what's happened here. Let me go share this. This is a CSV file from years ago, several years back when I was doing. In fact, this dates back to the community college days. I figure that that's a pretty safe file. And most of those people that were back in the day, there's no identifying information here, I don't think, but it may have. Now I think I took all that out of the original file. But what a CSV file does, it's a text file. And so it comes over and it's a text file that is separated by commas. And so, Excel is very familiar with CSV file. And so they bring it right in. And as you can see, this is a file that has to do, it's called adjunct, but it's basically for a research study I did when I was at community college, looking at the effect of adjunct faculty, percentage of adjunct faculty on beginning students, and how they did in terms of GPAs and from semester to semester, and retention over a year, and graduation and final GPAs and all this stuff, because we were trying to answer the question at that community college: did we have better success with full-time faculty in terms of preparing new students to be successful as opposed to adjunct faculty. And obviously the perception was that full-time faculty would be better. And so therefore we should be hiring more full-time faculty. And we had a dean that wasn't quite sure that was the case. And so she wanted me to take a look at it to see, well, maybe it's not. Let's see if we got data on that. And so I pulled from all the different databases to sort of cobble this file together so that we could look at students and things like credits completed and GPAs per semester and retention from year to year and part-time, full-time, and whether they had developmental coursework and whether the instructors in all those classes were adjuncts or full-time instructors or, all that stuff. And so, it was a fair amount of programming, but it didn't, it wasn't all that difficult. I did it, kind of over, I guess it took 4 or 5 hours to, find all the bits and pieces of data, because what you find is that, even in systems that you think are, everything would be consistent, you find a lot of times there are different definitions in different tables and different parts of data files, data bases. And so you might have one definition of full-time student in one database, and you have a slightly different number of hours in another database. And, so stuff like that you have to go back in and you have to, pretty much understand, read those definitions, understand what's going on, and you kind of end up with a file eventually that you massage most of that out of. And so that's what this kind of file is. It's drawn from lots of different places, and it's kind of a bridge from that. And, it's got a lot of bits and pieces of information in it, but it's really kind of a simple, straightforward type of file. But then a file like this can be pulled directly into SPSS because it will accept this file format. And so, then after, kind of cleaning up a file like this, which you hope whoever you're getting it from has done, but a lot of times they haven't. And another big issue in data files is what do they do if a value is missing? Because people will skip questions or not answer particular questions or things like that. And, a lot of times they'll enter some code and it'll be, 0.999 or 999 or 555, whatever code they come up with, there's no standard for it. And so you have to go back in and you have to, take all those data points out and just leave blanks. A common mistake is to take, data points that are missing and stick zeros in them. Well, if you stick 0, then that affects the computation. And another way of massaging missing data points is to take the average of that particular bit of information. What's the average for credits completed, and you just stick the average in for all the missing data points, and that way it doesn't affect it as much as if you put some other value in there or just leave it blank. So there's lots of little rules about manipulating data and cleaning data, but this is not a data cleaning course, so we're not going to spend a lot of time on that. That's another one of those seminars I ought to do for the doc program, is cleaning data. But so I have a file, and I'm just going to open up my SPSS.
While you're doing that, can I ask you what you found out in that study? I mean, were the adjuncts
The
Were they the
adjunct,
same?
what we found is actually that, let me click on this real quick. Okay, there we go. What we found is that the adjuncts were actually, in some places, students actually scored better with adjuncts. For example, in first semester GPA and in, I think, third semester GPA. And we didn't do a really deep dive into why, because, things were happening there, and she just was trying just to make a decision about where, how she was going to allocate some monies. And so we didn't have a lot of time. And so I didn't do a deep dive, but we talked with some students, some, sort of more anecdotal stuff and more, kind of looked at what some of the department heads were finding and things like that. And they actually found that some of their adjuncts had more recent experience, but some of their adjuncts, like to teach the beginning math class that a lot of these beginning students have to take. It's not the remedial, it's the next notch up from that, but it's the basic beginning math class. To teach that class, they almost always pulled in adjuncts. And, those adjuncts were, high school math teachers, typically, or middle school math teachers. And they knew more math than did the math faculty, or at least they knew more math at a lower level than the math faculty. And so the math faculty, regular faculty, didn't do as good a job teaching that beginning math class. We also found that there was no distinction between who graduated after 3 years and who didn't graduate after 3 years related to adjuncts. In other words, we didn't find a whole lot there. Now, the only thing we found that was somewhat meaningful was that the students that were part-timers were more likely to complete or graduate than students that were full-timers. And that one was a relatively easy one to figure out because the full-timers were almost all students that were doing the first 2 years to get an associate's degree, to transfer that associate's degree into a 4-year institution. And they were young. These were fresh out of high school kids, or just a couple years out of high school. The part-timers were almost all a little bit older, and they had a pretty clear career mission. If they didn't graduate or whatever, it's because they didn't need to. They just got what they needed, or they were working on an associates of studies degree, which is the technical degrees and things like that. So they were getting a technical degree as opposed to an associate's transfer degree. And so it made sense when you started putting, more light on it and looking at who those were. It turns out that full-time, part-time was really a proxy for age. And part-timers were more non-traditional students, and full-timers were more, traditional sort of high school students just trying to get into a 4-year institution someplace. And a lot of those, they'd go on institutions started doing the 1-year wait list thing. And so if you didn't get in, but you probably had enough, horsepower to be successful, but they didn't let you in because they didn't have a slot for you. A lot of institutions will now do this 1-year wait thing, where they say, okay, we're going to put you on a 1-year wait list. And if you're still interested next year, then you'll be offered admission before we put anybody else on a wait list. And they almost always get in the second year because it's easier for the community college just to admit people that they've already kind of looked at pretty closely. And so they left after a year. halfway through their associate's degree. And so it was, but it was interesting, and it's kind of an interesting anecdotal side story to that. The dean that wanted me to look at this, she was a good friend. I'd known her for several years. I'd worked with this community college on some grants and things like that. So I'd worked on her with grants, and Hara wanted me to do this. And then when I got about a year later, after I had gotten out there, I had left the community college and got the job at App. I had for 3 or 4 years, I've been doing mostly administrative stuff and consulting stuff. So I hadn't done a lot of your journal articles and things like that for 3 or 4 years. And so I thought, well, I need to get a couple of things published, or at least some presentations. And so I called her up and I said, Hara, do you mind? I'm going to take this data and I'm going to put it in a presentation to take to AERA. And we'll list you as co-author and give you, you can have an editorial, veto on it if I say anything you don't think's good in it or whatever. And if you can go to Denver next year, that'd be great. But I'm going to see if I can get it a presentation. Well, I did. And so when I took it to Denver, I had just checked in, and this reporter came up to me from Ed Weekly, which is Ed Weekly is, they publish the little blog sheets now pretty much every day, but they also do, these electronic journal thing, like a newspaper like thing every week. And I said, sure. And so, he asked me about the project, and he asked me about, the outcome from it, and did we find any real differences between adjuncts and full-time faculty? And I told him, no, we didn't. In fact, a couple of cases, the adjuncts did a little bit better. And there was not any instance in what we were looking at where the full-time faculty did any better than the adjuncts. And so it was a little bit counter, because the literature was really split. Some of the literature said, part-timers add vitality to the college and things like that. And the rest of the literature was saying, well, part-timers are really, they don't add to everything else that has to be done at the college. They don't sit on committees. They don't sit on task force. They don't write curriculum. They don't do any of these other things that full-time faculty have to do. And so we thought we were working in a gap there, a gap between the literature, which is often what you want to do. You want to, if there is a gap in the literature, you want to see if you can, provide some answer to that gap. So we got into that discussion a little bit, and then I had an awful lot of questions when I did the presentation. But what, I thought it went really well, and had a couple of journal editors that came up to me and wanted to know whether we had blown it up to a full article yet. And I said, no, it's still just a presentation paper. And they said, well, when you get it up to a full article, we'd really like to publish that. And so, be sure to send it to us, and before you send it to anybody else. And so I had a couple of, and that was odd. You typically don't get that. And so by the time I got back to the room, I had 2 messages waiting. And one of them was from a member of the board of visitors for the community college system in Virginia, wanting to know was this, how big the sample was, and all that sort of stuff. And I said, well, this is about 1,200 students and over a 3-year period. And we tracked and we followed them out for 3 years past graduation, past admission. So we'd catch graduates and, all that sort of stuff. And he said, well, it's very interesting. I'd like you to maybe present that to the board. And I said, well, I'll be glad to if we can schedule that, if you want me to do that. And then I had another message from the editor, from the co-author. She didn't go with me, the co-author, the dean. And So I called her back and uh, I said, hey, it went pretty well. And she said, I can see, because it showed up as the headline article in the overnight Ed Weekly online piece, that the study had indicated that, part-time faculty did just as good a job as full-time faculty. So, maybe that would have some impact on resources. Well, she had already had 5 or 6 phone calls from various bosses of hers by that time. And I said, well, it's true. I mean, it's everything. We can publish this thing if you want to. I mean, I've got a couple of journals that really want to publish this. We just blow it up a little bit more and, kind of get it up to 7,000 or 8,000 words and kind of follow it a little bit more. And there was a pause on the other end, and she said, well, Les, I'd like to walk away from this if we could. And I said, that's okay. I got other stuff I can work on. I mean, it's not the article that's going to make me or break me, but she said, I'm catching too much grief from this one. So, we need to just walk away from this. So we did. And we just left it hanging out there because, but I thought, okay, if that's the way it's going to be. But, as I had kind of a blanket approval to use data when I was at the community college. And as long as it didn't have any individually identifiable information, I had the blanket capacity to use that data later if I wanted to. And so there wasn't anything they could do about it. And they, but they gave her grief. And she's done okay now. She's a president of a college up somewhere in Michigan or Minnesota or something like that, up there where it's really cold, and loves it. I think she was originally from Alaska or something like that. So she's back up that way again. But yeah, it was kind of an interesting backstory to that. But that's some of the politics that you run into with data sometimes. So this was tricky. I'll see if I can find. I'm sure I've got it somewhere. The piece that I did for AERA and presented at AERA. I'll make sure that we put that in up on As You Learn too. That there's just so you can kind of see the conclusions we came to, and we kind of slow played it. And I said, this was just one college, one small community college, 4,500 head count, very rural, in a very conservative part of the state. So, we need to do a much bigger slice. And I had proposed to the state that they allow me to pull 20,000 student records from around the state to look at this. And of course, that got shelved too. So they didn't want to look at records. I suppose I could have got them with a Freedom of Information request if I really wanted to, but for Harris' sake and any other feathers I ruffled there, I just kind of walked away from that. But it was interesting. There are some politics sometimes involved in some of these things. Any other questions about kind of the background on that stuff? Okay. Well, let me share up my SPSS thing. Okay, you should be somewhat familiar to this. This is the kind of opening. Hold on just a second. Okay, this is the opening screen to SPSS statistic. There are really several different ways to get data into SPSS. The easiest way is just load a file, but you can connect it to different databases and do direct data queries and things like that. I suggest people don't do that because it's just, you're going to spend more time cleaning data in SPSS than if you put it in Excel or something like that and do all your cleaning in Excel, you know, getting rid of blanks and things like that. So I'm going to open another file. And I'm going to go over to, whoop, that's not what we want there. We want to go to desktop. I'm just navigating to the file where I stuck this file, where I think I stuck this file. Well, that's odd. All right, give me just a second. See where I may have put that thing. I'm going to stop the share for a second and go and minimize things for just a second. Oh, I can't minimize Zoom. I guess I have to close out SPSS. Okay. There it is. It's on the desktop, so I don't know why. Okay, let me get back in. Well, that was relatively stupid on my part. Let me, you know, most of the mistakes you make in SPSS are pure stupid mistakes, and I'm not immune from those either. Okay. I've gotten rid of the front screen, not because it was the problem, just because there's a step there that I didn't need to do. And so when I was going to load a file and open a data file, you have to identify the file type that you want to open. And so I'm going to go to desktop, and you'll notice that I've got indicated as a file type SPSS file, .save or .zsave. I really needed a CSV file type because remember that was a comma separated file. And on the desktop, and here's my adjunct file. And so when I open it into SPSS, it will, you'll get a crazy screen where you have, you know, all these things. It wants you to set the, you know, where the different data pieces enter and all that sort of stuff. I never really messed too much with that. I just kind of walk through all that, and it'll make all the right decisions for me, and I tell it next every time, and next, and finish. And so I end up with a data file.
Dr. Bolt, may I ask a question?
Oh, I lost the screen there. Excuse me just a second. Yeah, go ahead.
That looks quite a bit different from what I used last semester. Is that the same for everybody else in class, or did I use the wrong something?
Well, I'll tell you what, let me.
Mine did not look like that, Michelle, so.
Okay.
This does, this screen did, but the other ones did not.
Okay.
You didn't see the open screen then. You saw this. Were y'all clicking into an Excel file, I mean, a SPSS file that Tracy sent you? Yeah. If you have an SPSS file, if you double click on that, it'll automatically pull it up and load it right in. But if you're starting from something else, you're starting from an Excel file a CSV file, a SAS file, any one of 1,000 different format files, then that's the screen you will get. Now, once you load it in once, then you can save it out as a full-blown SPSS file. And if you want to work on it again, you just double click it in. So, if, for example, if I, let me stop that. I'm going to close this thing out real quick. And I know this isn't helping your comfort level with SPSS, and I apologize. I'm going to save this thing out as a Excel, as a SPSS file, and we'll call it adjunct 2 again. Put it on the desktop. So, and then I don't need the output file, and I don't need that file I just opened. So now I have it as an SPSS file on the desktop also. So this is probably what you did. I'll double click on that SPSS file. That's all I'm doing for adjunct. And it will pull up you probably saw it loading. And then you got to this. Let me share that. Well, this is doing okay. I'm saying that sarcastically, by the way. Okay, so you ended up with this file, or a file that looked like this. Let's put it that way. And you notice that there were two. Okay. So, and that's how you did it, right? You just double clicked on a file and you end up with this file. Okay. There's as I said, there are a whole bunch of ways that you can work with SPSS and load stuff into SPSS, but if that's the most comfortable way, that's fine, but you can load directly from Excel files and things like that. You know then that there are a number of different windows and different views in SPSS. The data one just looks like a regular spreadsheet. It's got some indication as to the type of file, as to whether it's just a general file or whether it's a numerical file or whatever. And it has also what's called a variable view, which is just the information about the variables, which ones are string and numeric and categorical and all that. It has a spot where you can attach a label to a file. You can just, for cred comp, the reason I did that is because most large database files or databases require you to cut off your variable names and to have no more than 8 or something like that, or 8 or 10 characters in it. And so you always abbreviate those things, and the label thing lets you, attach a full title to it. And if you have labels that are values that you want to attach to certain labels, if one means, strongly agree, or 2 means agree, 3, you can establish those values in what's called the values column. within the variable view. And then when you go back to over to the the spreadsheet view, you kind of get that. I need to make this bigger because it's going to be hard to see some of the stuff a little bit. Okay. So that's how you got your data in before. You clicked on, double click, you got it, ended up with this, right? Okay.
Yes.
You want to pay attention sometimes to the stuff that's over here in the output file. And I guess I got to get rid of the stop share for that. And I guess I got to share each one of those screens separately. This is the output file. And it's a useful file to know a bit about. If you were coding this directly into a computer, as we used to have to do. No, maybe later. As we used to have to do, like when I learned to do SPSS, I did it on key punch cards, on a key punch machine. And you would enter your data on key punch cards on a key punch machine. And you'd have a deck of cards, that's maybe that thick or thicker or whatever, depending on how big the data file was. And these are the command files. These are the commands. So this would be the exact command I would have entered if I wanted to pull up this file from this location. On a key punch card, I would have put get. Then I would have another key punch card that would file is equal to, all that stuff. And then I would have a data set name as the data set. In other words, it'd keep the same name. And the data window would be the front window in SPSS. Now, nobody does that anymore. I mean, because, the real data processors don't use SPSS anymore. They use a much more sophisticated languages and all that, but it still has retained all of its old Unix command codes. Now, these are useful because if you get a set of commands that does a particular thing for you, you can come over into the script file and just copy that and load it as script, like when you're opening a file into SPSS, notice the options you have available. You can open data, what's called a syntax file, an output file, or a script file. And this is just a basic script file. Or it could be considered to be a syntax file. And so if you have all that saved someplace, you just, you just enter, say I'm going to enter a script file or enter a syntax file, and I would paste all that stuff in, and then I would hit that little, there's a command up here that says run. I guess it doesn't light up until you actually highlight stuff. But you can have a run command that will automate and run all that stuff again, so you don't have to go through the same processes and all. So sometimes it's useful to have that script file and to pay attention to this output file. Any observations or questions, or God, I'm glad I didn't ask him about any of this stuff, and I wish he would just shut up and go away at this point. I mean, any of that quite yet?
I have two quick questions. Oh my gosh, it's echo. When you import the variable view tab, I know you may want to change your labels, like if you have categorical data and you need to say, male equals 1, female equals 2, whatever, you got to do that, right? So I'm just trying to think through, like, is this already in Excel, or what in the variable view do I need to make a note of to go check?
Well, you can, well, first, all right, let me get back over to the spreadsheet format and save that up, share that out. First, up here at the labels across the top, the variable names. If you see this little ruler, it's a numeric file. It's treated as numeric. Can be an integer file. You can have, like, see, these have decimal points, all that in. And these are numbers, but this is actually a term. You know, what term of the was this data from? And so this is not really numeric. It's actually a category name. And so I can go in here in the variable view. Did I lose y'all?
We're here.
Did I get the share? Did the share come up? Yeah, okay. So you see the variable view then.
Mhm.
Okay. This thing up here that was term, I can simply go in here and change it to a string. Which has the effect of converting it to a nominal measure, which is a categorical variable. If it's nominal or ordinal, it's categorical. If it's scale or general, it's numeric. And if it doesn't know what it is, if SPSS can't really figure out what it is, it makes it a string variable. But yeah, you can change variable types just that easy. Now, talking about the gender, like here's sex, string, it's a string variable, and that's okay. Width of 1. We know that it's M and F. If you go back over and look at the data view for sex, it's M and F. And if I remember in the way the data came in, M was first and M was 1 and F was 2. So if I go back over the data view, I can go over to values. And I can say that the value of M has a label of male, add that in, and the value of F has a label of female. And, you know, so there's all kinds of ways within SPSS. And let's say you're doing a bunch of response answers from a multiple choice thing. And so you have a Likert or Likert scale, and you have 1 is strongly disagree, 2 is disagree, 3 is agree, 4 is strongly agree. I could go in and put that in as a label. Then I could copy that label and just paste it into these other areas, so I wouldn't have to do that for every single one of those. And that changes really not much on the view over here, but you've changed the nature. See, now you have a term where it was that little ruler, numeric. Now it's this general, which just basically says it's an alphanumeric character. We're not quite sure what it is. And if we open up sex a little bit more, we see that it's a alphanumeric also. Now let's say we want to have sex as 1 and 2, a numeric value, we can simply oh, that little thingy up there is in my way. Well, that's unusual. Let me slide this down. Let me kill the share and slide this down a little bit because all of our commands are up near the top. And now we'll I'll share it back out. And so now I'm sharing again, but now I can see all my pull down commands. And let's say I want sex to be 1 and 2, because maybe I want it to be a numeric value, or what the normal convention is it's 0 and 1, but we'll do 1 and 2. I can transform data. See, there's a pull down here for transform data. Can you see that pull down menu, transform data? And you can do lots of things, compute variables, recode into the same variable, recode different variables, automatic recode, dummy variables, all those sorts of things that you may need to do from every now and then. And so I can just recode into a different variable, and I'll take sex as the input variable. I'll have a second variable and call it sex 1, whatever. And old and new values, old value of M, notice I made it a cap. You have to be very precise and use the exact alphanumeric character. I'm going to make it a value of 1, which I'm adding. Then I'm going to take female, capital F, made it an alphanumeric character of 2, which I add. Continue, and OK. And now I've created a new variable. Now it doesn't put it right where you're at. It puts it at the end of the data set. So here's a new variable I just created called sex. And it's obviously needs to be numeric. So I can just go over here into the variable view, and it treats it as numeric. I'm going to reiterate that because yeah, it's good right the way it is. And so now I have sex as both a categorical variable in M and F, and I have it as a numeric variable in 1 and 2. And so there's all kinds of recodes and things like that that you can do, and recomputes and that sort of stuff.
Okay, my second question is just a quick one. I just wanted to make sure I heard correctly. The output files, that's basically a repository of your queries, and you can just copy them and rerun them over and over again.
Yeah, essentially, yeah.
Okay.
If you save those, there's an option here. Different people do it different ways. I have a doc student I had a few years ago who's now she's a VP of a national clearinghouse for data. Some of you may know. Anybody know Chrissy Tillery? You know Chrissy? Anybody? Yeah, Chrissy is. She was a SPSS whiz. At least she perceived so, until I disabused her of some of her bad learning. But she always opened a script file, called a script file, and the things that she wanted to copy that she might want to run again, she would just copy them out of the output file and paste them into her script file. And so that way, you know, she could debug the script file. You could do the same with the output file. You can always change the variable names, do whatever needs to be done to meet the data requirement. But she used to do a lot of her editing in the script file. I always just did mine just in the, you know, the output file, because it was easy just to, you know, copy and paste right into SPSS. Other SPSS related about getting data in, you'll have plenty of questions, I know, as we start running some stuff here a little bit later. I tried doing this in the UDesk thing. It works okay. The UDesk version of SPSS has a little bit less functionality than the full, you know, computer version. And I guess they had to be careful about the, you know, the working RAM they had available and things like that. So they didn't, you know, this is a fairly large file here. It's got, oh, I don't know, 1,200 people in it. Well, maybe this one's got about 800 or 900 people in it. So it's 800 or 900 subjects and 25 variables, which leads to a fairly big file in space wise. And so this one didn't, it loaded okay, but there were some things that I thought, well, let me see if I can do this or do that. And it wouldn't do them. Either the option wasn't there on the menu, on the pull down menu, or it would just tell me that, you know, it couldn't run that procedure. So I think there are some limitations to UDesk. And if you're using that, I'll try to keep the files compact enough that it doesn't create a problem for it. Okay. Well, why don't we ask a question or two and see if we can do a run just to see what's working here. I'm writing down a question. Okay. Share that up. Okay, there we go. I don't know if you can see that or not. Let me see if I can make it a little bit bigger.
We can see that.
Can you see it?
Yep. Is there a difference between males and females on first semester GPA?
Okay, all right. And that would be a you know, a simple question to ask. And why might you ask a question like that? Well, you're interested in gender and you're interested in seeing if there are differences that are related to gender that you might want to delve into a little bit later and a little bit more depth. And so sometimes you just go fishing a little bit. And so we are wanting to know that if the independent variable which is gender, even though we call it sex in here, male and female, and the dependent variable is first semester GPA. Now, it's important to note what these variables, the nature of these variables. Male versus female is categorical. you're either one or the other. And I guess not anymore, but these days, back in the day, when this data was collected and we coded it, you were either male or female. However you determined that was up to you, but you were one or the other. Dependent variable being first semester GPA, we know that that's going to be a scale somewhere between 0 and 4, but it's a scale, which makes it a continuous variable. So every data point on that scale has an equal value to it. Now, this is a question, but it's also our alternative hypothesis is that we're kind of proposing that there is a difference. Our null hypothesis is no difference between males and females on this GPA. And so we have a null, we have an alternative hypothesis. We okay so far? All right. I'll let that stay up for a second. And then we'll do a quick run and make a run and see what it turns out to be. Okay. Let me stop that and go back over to the data file. And so we asked the question, is there a difference between males and females? Now, because we have a categorical variable for the independent variable, and a continuous variable, scale variable for the dependent variable, we're going to run what's called an independent t-test. The independent t-test with a random selection was actually built around the modern scientific method. That is really the model for the modern scientific method. An independent t-test with categorical independent variable and with 2 values and a scale independent variable, a dependent variable rather. That's was always the model for the modern scientific method. And so the first real methodology that was inferential that was developed was that particular model. So we're going to ask the question. We're going to, I'm going to analyze. Now, almost all analysis procedures start from this pull down. There's some utilities and things like that that let you kind of manipulate the data and play around with it a little bit and things like that. But almost everything starts from this pull down. And we are comparing means. This doesn't say t-test, but comparing means is where we do find t-test. And this is what's called a independent samples t-test. That's the basic modern scientific method, independent samples t-test.
The reason they call it independent is because the independent variable has 2 values, or because the 2 variable, I mean, is that
The
the
two
naming
groups, yeah,
convention?
the two groups are independent of each other. The two groups are different groups of people. Now, they're supposedly drawn from the same population. But we know that's not always the case. Now,
Oh, so you're comparing, because you're comparing the males to the females, those are two independent groups from the sample.
yeah.
Gotcha.
Now, I know the language for modern scientific method is control versus experimental. But so much of the work we do in the social sciences really is not a control versus experimental. It's a comparison between two different groups. And so, the comparison between males and females is essentially the same thing, except we know that they're dissimilar to begin with because males and females react differently to things. But we treat them because this is quasi-experimentation and not a pure experimental model because we don't have random selection. We're treating it as if all the assumptions for the modern scientific method are met, even though they were not. And that's why Stanley and Campbell and all those guys labeled this as a quasi-experimental, because it's not really experimental. The test variable, this is the variable for the dependent variable. In SPSS, sometimes it's referred to as the test variable. And so first semester GPA, you can see it's a scale because it's got that little ruler thingy symbol in front of it. And so it's a test variable. Sex is the grouping variable. Now here's the crazy thing we have to do. We have to define the grouping variable. And remember, it was capital M or capital F. So we have to define it. Group 1 is capital M. Group 2 is capital F. And so we set it up like this. Options. You have options always available in different stats. These are options that I'm not worried about. Notice this confidence interval percentage is 95%. And I'm going to let it talk about effect sizes. We'll talk about that. We'll just mention that right now, and we'll talk about it later. And so, okay. And so it will dump me. You're not seeing it, are you? It's in the output file. All right, let me get rid of the share. Go back over to the output file. And so this is the output file we get. It automatically generates group statistics. Males are, where's my little thingy blob? Males are, there are 438 males. Their mean score was 2.765. Standard deviation, which we'll learn more about, standard error we'll learn more about. Females had a mean of 2.86. And then we go down to the test table. Let's see if I can squeeze this around so we can see it all. Now you'll notice there's two lines here. It tests to see whether we can reasonably assume that these two groups could have been drawn from the same population. And if they're drawn from the same population, they would have what are called equal variances. it tests to see whether that occurred or not. And that test is not significant, which means this is called a Levene's test. It just happens inside the machine. This test is not significant, so that means we can assume that they were drawn from a similar population, if not the same population. And our significance level, the significance for the Levene's was 0.392, which is above 0.05. We're only looking for above 0.05 or below 0.05, excuse me. And so we ran a t-test and we find the significance level overall for the t-test is 0.139, which is greater than 0.05, so it's not significant. In other words, if we said there's a difference between males and females, there is almost a 14% chance we would be wrong. And we're not willing to live with more than a 5% chance.
So I have a question here because I got confused about this a little bit in Quant 1. I had to like keep reminding myself.
Okay.
Since it's a two-tailed, you're looking at the two-tailed significance. Are you looking for 0.05 or are you looking for 0.025?
Well, you're actually still looking for 0.05.
That's where, because I think we were taught you look for 0.025, and that's where I got confused a few times about what we're really, what do we
No,
always stick with 0.05?
Yeah, see, this is looking at even, even if it's a one-tailed, well, let me clarify that up real quick because that's an important thing we need to clarify. So let me go back over my little notepad thingy here. And all right, so what we're really looking at is this let's hit that. This t distribution for this question. The t distribution looks like a normal distribution. What makes it unnormal is that it varies according to sample size. And when you have, let me find another pen here. When you have, the larger the sample, the closer it is to a perfect normal distribution, but the smaller the sample, the wonkier the distribution gets. And by wonky, I mean, it could be flatter, the peak could be flatter, it could be more spread out. I mean, there's different ways that distributions can look, even though they're normal. And of course, at the center of the distribution is the mean value. Now, this is a distribution of t values. Distribution of t-scores. If we are looking at a two-tail, then we're looking at, I think this is where it gets a little confusing. We're looking at 2.5% of the area on each end of the curve, but it doesn't matter which end of the curve it's on.
Right.
And so we add those two together, and so we're still looking at 0.05. It's just that, it could be at either end of the curve. Now, if it's a one-tail, and find all my crazy colored pens here. If it's a one-tail, it's either 5% at this end of the curve or 5% at this end of the curve, but it's still 0.05 total. It just happens that we're only interested in one end of the curve. Now, as it turns out, if you take the two-tailed significance level and divide it in half, that's the one-tailed significance. But the one-tailed, it matters direction. It matters which end. Two-tail, it doesn't. Two-tail, can be either end. But, you know, the SPSS has already factored all that in. So,
I guess that was where I was getting to, like, is SPS taking care of it? We don't need to worry about
no, you don't need to worry about it.
necessarily 2 or 1. They're going to tell us whether it's significant or not.
Yes. And there are some tests that are tail doesn't matter. You know, they're because the distribution folds over the top of itself. And so, you know, whether it's one-tailed or two-tailed really doesn't matter. So they don't even test for that. But if you didn't want to run a one-tailed test here, and you had if this value were 0.1 or lower, say it was 0.095, that would not be significant for a two-tailed, but for a one-tail, it would be, because that 0.095 divided in half would be 0.047. But the directions, then you would go back up here and look at the values to see if the direction was correct, to see if the direction of the means was correct for that one-tail question. Now,
Can you say that again? Because you said if it was 0.95, I guess I'm going back to, do we have to do the division by 2?
well, you can. No, you don't have to. You can just run it as a one-tailed test.
Okay, I guess we didn't do that as far as I know in Client 1. We just ran them the same and then did it ourselves.
Yeah, if it's one tail, you just divide the two-tailed significance level in half. That's just quick, you know. So if it was 0.095 two-tailed significance, it would be 0.047 one-tail significance. And so it would be a significant outcome if you had a one-tailed question and a not significant outcome if you had a two-tailed question. So if my question were, say, instead of, is there a difference between males and females on first semester GPA, since there's no direction there, that's a two-tailed question. If I ask the question, is there, or do males score higher on GPA than females, then that's a directional question, so that's a one-tailed question. So how you would interpret that would depend upon, kind of what question you're asking. Does that help?
Yeah, I'm just still a little confused as to if we have two-tailed and we have a significance output from the t-test of 0.95 and we divide that by 2 into 0.0 or 0.4, wait a minute here, say 0.095, and I don't know if I'm doing the math right, but anyway, we get 0.047 as our two-tailed.
One-tailed. See, if you did, well, let me go back over here. Let me see if I can explain this to a little bit better.
My main question is, I just want to make sure I'm not supposed to divide that 0.05 in half.
No, you never do that. You would never do that. No.
Okay.
Yeah. You would only do that if you didn't want to run a one-tailed test, or you had to run a two-tailed test and decide that, hey, if I ask this as a one-tailed test, and it's in the direction I really think would be an interesting direction, I'll just interpret it as a one-tailed test. And you just change the number in the table without having to run it again.
I think that's what Client 1.
Yeah.
Because we were, when we did the calculations by hand, she wanted us to see the difference between the one-tailed and the two-tailed. But then when we did the SPSS outputs, I didn't know how SPS was.
Yeah, well, SPSS will mostly run a two-tailed test by default. but you can tell it to run one-tailed test.
Gotcha.
In fact, let me see if I can do that real quick. Let me get back over to the data. Something's going on with my mouse here. Well, I think it's about to die. So I'm going without mouse. I'm going on touchpad. This will be interesting. Given the amount of arthritis in my hands, this should be interesting, always. So let's say I asked the one-tail question. I asked, do males score higher than females? Analyze, compare means, independent samples, GPA, semester 1. Doesn't give you the option, does it, anymore? Huh. There used to be an option there where you could indicate if you wanted a one-tailed or a two-tailed. But it must be, they must have decided they didn't need to give you that option. That you could just divide it in half and figure it out yourself. Now, the other software program that I use when I teach a stats class, most of the time, this JASP program still has that embedded in it. You can tell it what your null hypothesis looks like, which means you can tell it whether it's one-tailed or two-tailed.
If you wanted to do it, would you change the confidence interval in the instructions there to 97.5%?
No, you wouldn't.
Just keep it the same.
Just keep it the same, just divide the significance level in half.
Okay.
Yeah. I don't know when they dropped that, but it used to always be able to let them know, did you want one-tailed or two-tailed? But I guess in, sort of trying to be more efficient, they decided to just assume that you could divide something in half. I don't know. But it wasn't too many versions back. It might have been 3 or 4 versions back. You still were able to indicate that, but I hadn't noticed it on that one. Other questions? Okay. Shoot, 5:08. Can you all stand at 10 more minutes? I'll pull the trigger. I'll pull the plug for the evening if you can stand at 10 more minutes. I just want to make one more thing relatively clear. I'm going to pull up descriptive stats on first semester GPA. And I don't know why they do minimums and maximums. I never do minimums and maximums. Variance, standard error of the mean. Continue. This is just and then I need to get you over to the output screen. Oops. No, that's not the output screen. Share output screen. Share. Okay. All right. It's hard to do with touchpad sometimes. We're not used to that. Once again, notice the script file stuff up here. And these are, each one of these lines is just an actual command you would enter in, okay? But the group statistics that I just ran would be down here. Okay. And so you've got different statistics here that you need to kind of understand the relationship between them. Well, that didn't quite do what I wanted to do. Let me run that again real quick. So I'm over here on the other screen running that real quick. So that's odd. Okay, now forget it. Notice the stats we got here. We've got the mean, standard error of the mean, standard deviation, and what they call the variance. You really don't need variance because standard deviation is the square root of the variance. And so if you know what variance is, or you know what standard deviation is, you know what the other one is. So if you square up standard deviation, you'll get variance. If you, you know, take the square root of variance, you'll get standard deviation. Notice here we have standard error of the mean. Standard error of the mean is the equivalent to standard deviation for sample means. For this particular, these two samples, you remember how when we watched the little birdie thing, little whatever it was, I don't know, dragons and bunnies, I guess. When we watched the little dragons and bunnies thing, they talked about how that when you have samples, the sample means will always or should be normally distributed if there's nothing systematic affecting that. And so instead of having standard deviation for scores in a normal distribution, we have standard error of the mean for representing random error among the distribution of sample means. So if we kind of think about that, I just didn't want to leave this idea hanging till next week. When we have a independent t-test, the formula for that is one group mean minus the other group mean divided by standard error of the mean. Standard error of the mean. And if we were looking for just a z-score on an individual score, that would be the overall mean, population mean, minus a particular score divided by standard deviation. And so all of these different statistics are going to look like that. There will be a comparative on top, which basically provides us with the total error. And on bottom will be a random error, estimated random error. And so the form looks to be exactly the same. And we'll look at 2 other t-tests, the next time we get together, along with standard normal distribution, because now we need to go back and pick that up so that we can make the connection between standard normal distribution and distribution of test scores or different scores. Now, did I just screw everybody up with that?
Could you possibly send us something like an easy data set to like play around with that? I feel like I'd have more questions if we started, or if I started running some of these, and then I would realize where I'm not understanding.
Sure, yeah. Well, in fact, I could send you the data set that we're playing with. I'll post that up, if that's okay.
Okay.
Is that too complex?
No, I just think I feel like I don't know what to ask yet because I'm not.
Okay. And I will even send it to you as an SPSS file. I'm just not used to doing that. I'm sorry, folks. I don't, I think that all the shortcuts that you take trying to get people to understand stats on the front side come back to haunt you later. So, but I'll give you an SPSS file later. I'll put that up tonight when I put up the recording.
Dr. Bolt, do you have a preference for whether we use the computer or the online version?
Not really, because I don't think we're going to get so complex that they vary, that they differ from each other. I think there's some limitations on the online version simply because they're just saving memory. I think they don't have enough working memory on UDESK to let it crank for a while. And the desktop version is limited by how much memory you have on your computer. I mean, it'll eat up all your memory if you want it to, but it's just limited by that. So it's probably the desktop version is probably going to run a few things a little more intricately than the online version, but I don't think for what we're going to do in here, it's going to matter more or the other. So if the UDESK version worked for you, use it. Yeah. Like I said, I played with it the other day and analyzed some stuff on it. It works pretty well. The only problem I had with the UDESK was getting the data files into over on UDESK. Because I guess maybe it's faculty or something like that. I was having to use the UStore drive. And for some reason, the UStore drive and the UDESK drive weren't talking to each other too well. But it may have been a problem with too much activity at that time or something like that, but I don't know. That was the only problem I had, was getting the data files in, but I figured it out after a while and they got them over there. Yeah. I assumed you could just drag and drop them, but you can't. I mean, I guess as a virtual cloud-based desktop, you can't. They won't let you do it.
Now, I used my Google Drive, I think, last semester for Quant.
Yeah, Google Drive may work. Yeah, I didn't think about that. I guess I could have dropped it on Google Drive. Yeah.
I would drop it in a folder in Google Drive, and then I could go in and UDESK in Google and pull it right into it. That's what I did. I don't know what anybody else did.
Yeah, that might be worth a try. I didn't even try that. I wouldn't, I thought I could do it directly, but it wouldn't let me pop them over there. And finally, I did get them up on UStore, but even that's not easy. So maybe the Google Drive's the way to go. Put them on Google Drive and go over there and go. How did she provide them to you? Oh, you had a copy of, you had a desktop copy of SPSS. Okay.
I used UDesk and a desktop copy because it got to a point where, I'll be honest, I went to Panera Bread to do my homework. So I ended up using UDesk, and she gave us the files on ASU Learn, if I remember. Like we had to
So
go
you were
to,
logged into Google anyhow.
yeah,
And,
if I remember, someone else correct me, but we went, I went in and she basically had a folder with everything preset in it, the files that we needed for the workbook.
yeah.
And you had to download that and put that in a folder to get to it.
Yeah, it makes sense to do that if you're going to use a book. I mean, it would make sense to do it that way.
Yeah. I think that's part, I guess, where we're a little, where I'm a little confused. It's because we're used to getting the data and then manipulating it following what the book tells us to do. So
Yeah, that's a nice way to start.
I'm trying to put the pieces together to form exactly what.
Yeah, it's a nice way to start, but you know, if you're going to do, you know, data or data that you're going to run or data that you're collecting or whatever, you need to have, you know, just the facility just to throw data in there and understand what you need to have to. I mean, it's important to know, you know, you had a categorical data point here and you had a continuous data point or a scale data point. You need to know that and what that means for all these different models. So I don't know whether that book dealt with that or not. I haven't found one yet that does a really good job with stuff like that. But,
I don't feel like it did. I feel like I'm still a little confused on.
all right, well, we'll try to rid that confusion. We'll do as many of these sessions we need. I don't do, you know, all of our sessions won't be like this, obviously, but I do want to do enough for you to feel comfortable in SPSS that, as you say, and Lauren, as you say, you know which question to ask, you know what your questions really are. And maybe that's what we've got to get to. But we'll pick up the pace a little bit next week, and I'll throw some material up there, along with the file, along with the recording, and so you can have, you know, a little bit of time to play with it and figure out kind of what you can do with it. And my thought process here was simply to look at, you know, as we look at these articles that I'm going to be giving you, as we look at these articles, to look at the analysis they did, you know, the procedures they ran, the analysis they did, and then go ahead and run that on another piece of data and kind of point out as we go along the kind of how the interpretation occurred and how, you know, they kind of worked with it and all like that. And so that, I think we'll still get there pretty quickly, but we need to make sure you're a little bit more comfortable with it, I think, before we jump in at full force. But yeah, you can play. I encourage you to do that. That's the only way to learn stats is to play with it, is to play with the file. You know, to get in there and, you know, figure out why it won't let you do something, or if it won't let you do something, ask that question. Why can't I, you know, that's a good question. And then we can, you know, troubleshoot it and debug it and, you know, go back through it and figure out why that didn't happen. In most cases, it's either because the data points aren't right, you're trying to run wrong kind of data, or the wrong procedure on the wrong kind of data, or there's some option or something that you've set, maybe inadvertently or maybe on purpose, whatever, that's making it difficult to run. Because you know, SPSS doesn't know your level of sophistication. It'll run anything you tell it to run. And if you tell it to run the wrong thing, it'll try to run it. It'll run it. But what you get may be nonsense. And so, you know, that's the danger in that. So we need to figure all those things out. But yeah, I'll put the data file up along with this recording and we can go from there. Don't go away too frustrated. I mean, come back. I mean, I'll be here next week and I'll be feeling tip top, I'm sure. And then we'll kind of go from there. Other questions, other thoughts? I mean,
I just want to clarify, is there anything formal, I guess, formal homework for us to do next week? You said play with the data
You know, I
set.
could, when I put up the data file, that data file, I can ask you a few questions that are, we'll stick to a t-test, independent t-test. I can ask you a few questions, a couple, 3 other questions. I mean, it makes sense. You can look at the full-time, part-time thing. You can look at, you know, I think there are graduation things on there, graduate or not graduate, things like that. We can look at, you know, sort of binary categorical outcomes and see if they're attached to, you know, GPAs or things like that. Yeah. So I'll put up a data sheet, the recording, and I'll look at a list of questions that are all like the same independent t-test and see if you, and feel free to, you know, play with them and run them. And then we'll start there. We'll start talking about those first and kind of see where you're at. And hopefully you all are there, and then we can very quickly jump on to something else. How's that? Good. I'm glad somebody knows what this class should look like. I'm still working on it. All right. Honestly, you just have to tell me what you think would be the appropriate way to go with things, and I'll be perfectly fine with it. And I'll tell you if we can't go, if that's not the optimal way to do it, but in most cases, I'll follow your lead with your questions, because I mean, I've been doing this for a long time, way back from the key punch machine. You know, the nasty thing about entering data that way was that if one card had an error on it, it stopped running and just spit out all your cards, and you had to start from scratch. It would tell you there's an error on card number whatever. And the problem is you were in a line with, you know, maybe 30 or 40 other grad students trying to run stuff in the middle of the night, because the only time we got access to the mainframe was after 11 o'clock at night. And a whole new, you know, whole community grew up around those doc students sitting there in the middle of the night, 2 or 3 o'clock in the morning, trying to run data. And if you made one error on one card, spit it out. And you'd have to figure out what the error was, go back in, correct it on a key punch machine if you could get a hold of one. There was always lines for those. And then submit it again and wait for an hour, hour and a half for it to get through the queue and get run. And then, yeah, I don't know how many times I would make an error on the card and make an error on the very next card. And you just, you know, simple little thing. You want to run a t-test and might take you 2 nights to do it. But, you know, things have changed quite a bit. Now it's all, you know, pull down, point and click and all that. So it's really, but, you know, you did learn early on all the intricacies of the coding and all that. And that helps sometimes. We try to figure some things out, but yeah. Just another war story. I'm sorry, you know, like 7 miles uphill in the snow just to run a, you know, deck of cards or whatever. Okay, folks, go have a good evening. Relax. Everything will be up there later this evening or first thing tomorrow morning. It depends on how long it takes to process the video out. And then we'll go from there. And I will see you next week. Have a good one.